Sorry for my technically challenged skills here. Okay. So now we will get started. Instead of what makes a georeferenced image, we'll get into that later. We're going to talk about what is imagery, and then what makes georeferenced image, creating mosaics, and then there'll be a practical exercise. So hopefully you've all received the email with the link to download Google Earth Pro, and there are also some Excel documents and images that can be downloaded or should be downloaded. We'll be using those in the practical exercise. So if you haven't done that yet, you might want to do that while I'm talking. Or we can take time at the end and do that too. So, okay, so what is imagery? Imagery can be defined, and this is a Webster definition here: pictures produced by an imaging system, the product of image makers, figurative language, and mental images. And we're going to use that mental image right now. So the saying is, a picture can tell 1,000 words or speak 1,000 words. So I want you to visualize in your heads right now a cow in a field. So now you got that mental image of a cow in a field. So outside of a cow in a field, what kind of other information do you think we can pull from that image? Well, you can look at your mental image and go, what kind of cow is it? What type of field? What time of day is it? What time of year? All these things can be pulled out of that image. That information is there in an image. Analysts can tell you sentences. So as we were saying, they see that image and they're identifying all those little parts within that image and pulling it out. So you can go from an image, you can go to broad overviews, to down to the minute minute details within an image. So what is imagery analysis? Well, it's defined as the extraction of meaningful information from images, mainly from digital images, by means of a digital image processing techniques. So you can either visually use your eyes, or there are softwares out there that will help pull out those details in the image, and also help you, I won't really say alter, but change the components within it. So there's many different types of imagery. You have like infrared, near infrared, photographic or photogrammetric. Yeah, photogrammetic. There you go. Imagery, which is your basic photo imagery, and LiDAR. There are also other types of imagery like bathymetry, which is basically LiDAR for underwater. All these different types of imagery utilize different elements or spectrums in capturing that imagery. And by manipulating the elements or components in there, you can bring out differences in the spectrums or in what you're looking at to help you identify what it is. And then also in analyzing images or imagery, you look at activity, what's going on in the image, focus, what is the focus of the image. So you can have a picture of activity, say it's a football game. The focus of that picture is generally going to be the center of the image. So if the screen was the image, don't get too wild with the cursor. This whole screen was the image, the focus would be here in the center. That's what the photographer or the image taker wants you to focus on, is what's in the center. But as an analyst or analyzing imagery, that's where you start, but you also look at the outer edges, because the outer edges will tell you more of what's going on. And then to add to that, the culture or environment of that subject image. So where is it? What is the surrounding environment like? The surrounding physical and social culture? How does that affect what you're looking at? And we'll get into that a little later this afternoon too. Other things we use to identify things in images are shadows, shapes, and positional relationships. So shadows, as my fellow instructor always says, shadows are your friends. Shadows help you identify what's in an image. So you can see the shadows, you can see an object, you don't know quite what it is, look for its shadow. And the shadow often defines what the actual image is. Shapes, obviously there's certain shapes in nature that just don't occur naturally, and those will give away what's down on the ground or whatever you're looking at. And positional relationships, so where it is in relation to whatever else you're looking at, can help you identify or indicate what you might be looking at. So here we have an image. And it's a residential area. So here's where you get to participate. You can turn off your mics and answer when I ask questions here. It'll make it more interesting. So it's a residential area, but what else do we see?
A car.
Yeah, there's a car. What do you notice about the car?
It's traveling straight. It looks like it's just going down the road.
Mm-hmm. Does it have a shadow?
Just a little bit. Looks like a little bit.
Yep, it's got a slight shadow to it. What else do we notice about the area, the image?
It would appear that the roadway surface is compromised.
Yeah. So if you were doing a survey of road conditions, this aerial image could provide you with some good information on that you might not be able to see from standing on the ground looking down the road. What else do we see?
I'm guessing it's springtime. It's before the trees have started to bloom.
It's a good analysis, yeah. As I say, why do you think it's spring? I've said the trees are starting to bloom. What other indicators might be out there to tell you that it's spring? Look at the yards. Are they full of leaves? They're not. If it was fall, you probably have a lot more leaf debris on there. But yes, the budding of the trees does strongly indicate that it is springtime. That in the absence of actual leaves. So what else do we notice about the picture?
Looks like it's a midday shot.
Okay, why do we think it's a midday shot?
Shadows are on top of each other, pretty much.
Yeah. Shallow shadows, yeah. There's not much of the shadows. That's like when she mentioned that the car has a slight shadow. Yeah, that's generally what that indicates, is the sun is more or less directly overhead. So by looking at this, we've been able to determine the time of day, time of year. That's about it.
It's probably not in Southern California.
Yep, that would be a guess. I was gonna say we could try and nail down where it is, but there's a lot of area where that could be, but Southern California would not be one of them. Or Arizona or New Mexico. But no. So that's how we try and identify things. What is this right here? This is the object, that's the shadow.
Stop sign.
Yep. And you notice you see the stop sign here. There's another one on this side over here. Little longer shadow. What about this right here?
Yeah, it's a light pole.
It's a street light. Same with over here. So you can tell, if you look right at the pole, you wouldn't necessarily know it, but you see the shadow. And you're like, ah, I know what that is. So,
Maybe you could calculate how tall those poles are.
could, depending on the shadow length, time of day. There are ways of doing it. It's not exactly a good shot because it's directly above, but the measurement of this, the pole here compared to a measurement of a known object on the ground, there are ways to do that to figure out what the length of that pole would be. But yeah, you can do that type of thing. Okay, we've got another picture here. This is a tough one. What is this?
Looks like an airport.
Yeah. And now for the obvious question, why do we know it's an airport?
The planes.
The planes, yeah, dead giveaway. So on this one, we've got an airport. Again, we can see like condition of the runways and the taxiways here. What about time of day?
Still looks like midday based on the weather vane shadow.
Yeah. Oh, and that, by the way, is that what you're referring to as a weather vane?
Yeah, I think so.
Yeah, that's actually a jet,
Oh, is that right? Okay.
a small fighter jet. Yeah.
I mean, that could tell us where it possibly is, because how many airports have a fighter jet in the front of them like that?
Yeah. Yeah. So, and the other thing, this was taken from Google Earth. And if you're looking at it on Google Earth, and we'll get into this a little next hour, but it gives you the latitude and longitude right here of wherever the cursor was when the picture was copied. So if we had this up on Google Earth and I moved my cursor over the aircraft there, it would give me the exact latitude and longitude. So location would be fun to find, easy to find. What time of year is it?
Well, if this is agricultural, probably it looks like a field beside it there. So there's no thing coming out of the ground. So it's either been churned up or it's setting idle for the winter.
Okay, it is agricultural land. If it were winter, what would we expect to see in the field? It may have been turned up for winter, but if it was, what would we also see in the field? There'd be a lot of stubble and debris. The other indicator is, what is this here? Anyone have any ideas?
Runoff.
Yep, that's a drainage. I don't really want to say a ditch because it's not really a ditch in the field, but it's a low spot for the field to drain. It's field drainage. And these areas here, these darker areas, that's where the ground is still saturated with water. So this is actually in the springtime. So less field debris, more dampness in the ground. Anyone know why all these cars are parked here? And Zach, you can't answer this question.
It's probably a car park.
This is the aerospace campus for Northland. So this is a school building here. These are the old hangars here. There's new buildings in here. And that's our maintenance hangar there, Sorenson hangar. So easy for me. I know this place. Okay, now something a little different. Anyone know what this one is? It's kind of an obvious answer. Yes, it's a farm. But this area here is a research farm. And all these are individual crop plots. So as you can see, some of them aren't planted, like over here, others are planted, and in varying degrees of health and condition. If I remember right, these are soybeans up here, and this is wheat. What do you notice about the wheat here?
I mean, it appears to be a little more less dense. So you can see a little gray stretching through. So maybe they're spaced out a little bit.
A fair assessment. If we could zoom in better, you'd get closer, you get a better idea of it. What that actually is lodging, which is where the wind has blown the wheat over. So a heavy wind has come through and blown the wheat over, and that's caused some lodging in there. And that's what the lighter color is in the wheat. We also have another phenomena out here. You'll notice in this field, it all looks the same except for these blotchy patches through here, especially the lighter ones. And that is, the green part is it's rye field, ryegrass, but the blotchy parts in here is actually winter wheat, which isn't necessarily a weed unless it's in your rye field, then it's a weed. So the fun things we do. But that's what you can do with imagery on this is you identify where those problems are. And then you can draw polygons around them, mark those, and import that into the agricultural software and create spraying prescriptions for herbicides and nutrients, fertilizers in the field. So instead of having to broadcast spray the whole field, you just precision spray the areas that you need. So that's a use for that. Okay, another scenario. Obviously, this is not Minnesota. What do we have down here?
It looks like a crater.
Yeah, it's a depression. How do we know that?
The shadows of the side.
Yep.
And there's a bit of perception of depth as well.
Yep. The shadows. And what do we have here? Besides a big A.
And elevation.
That's a hill. And this would be a ridge, which makes these ravines. and fingers in between the ravines. So by looking at that and identifying those features, we can see or better perceive the elevation in the image. What about the terrain? Lush vegetation or sparse sagebrush?
Yeah,
It looks
small
like more-
rocky.
Well, it's more sparse. We've got a lot of different things in here too. It looks like residential over here, industrial up here. This one I'm kind of out on. I can't tell if that's residential or industrial. Could be a mix of both. But what do we have right here?
Riverbed, dry.
Yep. It's a dry riverbed. So where do we
On the
think,
bridge.
say again?
On the bridge.
Yep. So where do we think regionally this might be?
Southwestern United States.
Yep. Does anybody know exactly?
Tucson, Arizona.
Yep. That's it. A mountain in Tucson, Arizona. Anything else you see in this image that stands out?
The large A on the hillside.
Yeah. There's no secret to this. I'm just asking because I've covered it a couple of times, and as you become more familiar with your images, sometimes you forget about it, you miss things. So. That's all I have for that part. We can certainly pull up Google Earth here. Take a look at some other imagery. If it'll show. Got buried it. Where'd it go? Well, that doesn't work well. Oh, that's not helpful. Meow. Take a look at some other imagery. Then. Okay. So this is Google Earth Pro. In case you're wondering, we'll come back to this guy later. Somebody pick a place, any place. Anyone?
How about Mount Zion?
Mount Zion. I can find it here.
It looks like the Southern California coastline to me, but
Yeah, that's where it was. Trying to get to Mount Zion. You knew if it's gonna send me there or not. I'm trying to get my bearings in here. That looks to be about right. Mount Zion, Utah, right? It's not taking me there.
it's hard to tell, but it almost looks to me like that might be the Salton Sea down in the left-hand corner there.
There?
Yes,
Yeah. That's what I was thinking. The Salton Sea or the Great Salt Lake? I think that'd be the Great Salt Lake.
yeah, that's too far north for the Salton Sea.
Yeah.
So you're probably right. The Great Salt Lake, which puts this all up into Utah.
I mean, you're right there at Area 51. You could just zoom in there.
Oddly enough, you mentioned that. Let's see, I can't think of. It's Elbow, California. So Area 51 should be, I'm guessing somewhere in here. You know what happens if you zoom into that area in Google Earth? It's no big earth shattering thing. It's not like, sirens and buzzers go off or something like that. For some reason, my Google Earth is just not cooperating. But what happens is the screen becomes very blurry. Is what happens. So they just blur it out. That's how they deal with it.
Yeah, they don't want you to see those aliens or those high-tech 50-year in advance spaceships and everything.
So my screen. I try and share stuff, and this is just acting weird on me. Okay. So, yeah. Salton Sea. 51. One thing you can notice, you do see like some terrain features, but if you tilt the world, as they say, press down on the center scroll button on your mouse and then move it forward and back, it'll tilt your world, which really becomes rather outstanding when you get into 3D imagery. So it can give you that different perspective of the land and the terrain. It's not cooperating either. So let's see, let me give this one more try here. Here, it's not wanting to cooperate. So we'll have to try and make do with this one. Any other areas you might want to take a look at? Favorite vacation spot, historical area? Can't take you to the bottom of the ocean though. Wish I could.
How about there where the Colorado River empties into the Gulf there? Yeah, interesting to see what's going on in that basin.
Trying to see where the river dumps. You're talking about this area right in here? Or up further north? So it's looking to me like it's dumping here. Wow. Yeah, that looks to be the Colorado. Okay. Sometimes it takes a while to catch up with itself.
Well, now that dark spot you're seeing there, that is the Salton Sea. Then as you keep going farther, the Colorado River is the border between Arizona and California. And then it dumps there into the Gulf.
Yeah. So if that's the Salton Sea, then it's got to dump into the Gulf here.
Yes, that's correct. Because that's Mexico to each side.
So you'll notice the plumage here. And that's where the silting comes down.
And that's interesting because it gives us an idea of the depth of the water and the mixture of the salt water and the fresh water. So lots of information there.
Oh, yeah. Yeah. And there's, depending on the imagery you're using and the data, you can get even deeper into that as to just how much.
And, you know, from an agricultural side, again, I'm from Southern California and this is an area of my interest, but you can see the desert there, but then as you go farther north, that's all irrigated farmland, everything south of the Salton Sea, and it's all irrigated because of the Colorado River going through there. Without the Colorado River, you know, a lot of the vegetables we're getting in Minnesota during the winter time wouldn't be there. So,
Yeah, no, I agree. Yeah, that's It's a huge source. And then the Salton now, that's pretty much landlocked, to my understanding. There's no,
Oh, yeah,
outlet.
absolutely. Yeah, the Salton Sea is actually an artificial sea. It was created back in the early 1900s because the irrigation dams, et cetera, broke and allowed it to be flooded. And then over the years, because there is no natural input, it's just dried up.
right? Which makes me wonder, what if they, how could they push that water out? And if they did, where would it go? Because what are the ecological impacts of throwing that into the ocean or draining it south into the Gulf here?
Well, you know, my students tell me I'm old as dirt, but I can remember going to the Salton Sea when it was a beautiful, big, huge sea with fresh water, and you could water ski in it. It was a great area. And of course, now over the last 50 years, it's just shrunk down and there's such a high salt content, nothing lives in it. But yeah, it was artificial to begin with. And at this point in time, the water is just being reclaimed by the earth.
Might be able to mine salt off it later.
Yeah, there you go.
That's about all I have for this session here. Before we go on break, are there any other questions? Comments, input? Okay, we're back. And yes, I finally got my Google Earth up. So here's Zion National Park in Utah. And as you can see, you can zoom down. As you tilt the world, you can get a better idea of the relief. That's if you have the terrain clicked here. If you don't have the terrain clicked, it makes it pretty flat. If you turn on the terrain feature, then you get a lot better. So more fun with that later. So any questions to begin with before we dive into geographic information systems? A brief overview. This will be by no means a thorough investigation of geographic information systems. Especially if we're talking ArcGIS, because you would need a 4-year degree or a master's to capture everything in ARC. It can be pretty intensive. Give it another minute or two here. So let Tom know in the chat if you want me to keep the webinar open over lunch. It's kind of an open talk forum. If you do, just ping them and say, yeah, you'd like me to keep it open over lunch. And we'll do that. And we'll get started here. So Geographic Information Systems, or GIS for short. So when you hear that term GIS, that's what it is. It's a Geographic Information System. There are lots of different ones out there. Google Earth is kind of a rudimentary one. ArcGIS is probably the most widely used one here in the US. In Europe, ERDAS is very popular. And you also have ones like QGIS and some other entities like John Deere has their own system. Titan Machinery has their own, and so does Caterpillar. So there's several different companies have their own different geographic information systems that they use. Some more tailored to their own specific purposes. So, understanding geographic information systems. What is GIS? It's very shortly and quaintly, it's a digital map, but it's more than a digital map. So traditionally, up until about the 60s, we had traditional paper maps. So your typical fold-out road map, your USGS map, topographic map. There's many different kinds, but they are all limited as in just the paper that it's on is what you're working with. So that's the only area you have. Large or small, it's that area. With GIS, or Geographic Information System, a digital map, you're able to cover anywhere in the world that's been mapped. As long as somebody's mapped it and recorded it, you can get there. Using satellite imagery and the traditional surveying information. And that is all tied to the geolocations, which we generally refer to in latitude and longitude, although there are several different ways there of recording latitude, longitude. There's different systems, whether it be the lat long hours, minutes, degrees, or it's a digital formation, all depending on which you use. They can all be converted to a system that'll work for whatever system you're working with. So it's digital representation of the Earth, and the advantage that GIS gives you is spatial relation. So you can better see the environment, terrain, and other features and information that are around the specific subject you're looking at, how that can influence it or how the subject can influence that environment. So it's like we were talking about the Salton Sea, how the river influences that area as far as agriculture, how the sea and desert climate environment of that area can influence the Salton Sea and agriculture. So traditional mapping, got several types. You typically see like your street maps, topographic maps, different scaled maps, but they're all flat paper maps is what you use. Now people would make relief maps where it's actually scale representation of the Earth's terrain. Those are possible and have been done. But now you've got that all in digital format. So you can expand or shrink in that area rapidly and at will without having to print out a new map. And then you have relief maps, obviously. So like your terrain maps here, topographic maps with relief. And all these samples are taken off of ArcGIS. These are different types of base maps you can put on. So depending on what your subject matter is, you can pick a base map that better fits what you're looking Traditional maps, again, flat, one-dimensional, limited expansion, digital maps, physically flat, so your screen is flat, but multi-dimensional image, expandable over track. Okay, choosing a base map. So you've got a lot of selections, but which one am I going to choose? And that's going to directly relate to what is the subject you are working with. Are you mapping logistics routes for a company, or are you mapping demographics for a business or for Center for Disease Control? Are you mapping economic or political demographics? These could all impact which base map you're wanting to have. So you have a wide variety. The nice part is you can pick and choose, switch and swap as you're going through. You might start out with, say you're doing an economic demographic of an area of Appalachia. So you're looking at that just on the flat. Where are the cities? Where are the roads, the businesses? You've got your different layers in there showing the information. But you're like, how does that fit with the terrain, the mountainous terrain? Does that have an effect? So you switch from your flat street map to a terrain model. And that can give you a different perspective on how the terrain impacts the economics or the economic movement viability in an area. So base map should be reflective of the type of map information you're wanting to convey. So now we come to building layers. So how many of you as a kid, I hope this isn't dating and aging a bunch of people here, had a flip book? It's a little book and each page had an image, but the image was ever so slightly different from the previous one. And go ahead, Lee.
No, just raise my hand. Yeah, I'm old enough to remember them.
Yeah. So as you flip the book, flip through the pages, the image would move like a motion picture, which is basically what motion pictures are, is just a string of still images. And the old ones, you could pull out the tape and you could see the individual stills of the image. On digitals, now it's more of a fluid thing, but the fundamentals still apply. At any point in that fluid stream, you can stop and select that still. So it truly is more like a flip book. It just has a lot more pages. So when we're talking layers, so I'm sure you're going, where's he going with this? So when we're talking layers, that's what layers do, is it's like your flip book on top of your map. Each layer contains different information. And that information, as it's laid over each other, layered over each other, begins to paint a different picture. So you begin to understand better how things are relating and being impacted and affected. So 3 basic types of layers are point layers, which would be a pin on a map or a point on a map. Polygon layers, which is a circle, square, multi-sided border, boundary. And image layers, which would be a photogrammetric image, could be a LiDAR image, could be a hand-drawn image. But you can put on an image layer. So importing images. So when you have an image and you want to import it into, say, Google Earth. And if I didn't mention it before, I use Google Earth because A, it's free, anybody can get it. And B, it covers the fundamentals of what we're trying to do with GIS. So you can do all the fundamentals with Google Earth. When you graduate to ArcGIS, then you can do all kinds of crazy stuff. Okay, so when importing images, you need to ask yourself a couple questions first. First one is, what is the file format? That's kind of the translator, shall we say. You need to find what the lingua franca is. And for you old people, you don't, like me, you know what that means. For the younger ones, that's the universal language. What is the universally understood language? So with file format, you just have to understand what the GIS will accept. What format is it looking for? And if it's not in that format, if your image is not, you'll have to change that format so that it does. The other thing you need to ask is, does it include metadata? And the metadata is the locational data tied to the image. So without that, it's not going to know where to put the image. And then is conversion required? So are you going to have to convert the file format? So any questions on that stuff? Okay. So images are usually saved in one of several formats. Google Earth uses KML. JPEG is another common image format you'll see. Also PNG and TIFF files. And I think it's either JPEG or TIFF, it might be TIFF, is kind of the universal. It's the one that's accepted by most systems, very easily converted and imported in. So common uses or common issues. This one's a fun, unfortunately, I didn't have an example of it. You import your image, it has metadata, it's the right file format. You imported it in, it's supposed to go to Fargo, North Dakota, and it ends up in Honduras. Why is it in Honduras? That's a coordinate system conflict. So the coordinate system of your GIS that your GIS is using is different from the coordinate system on the image. So you need to go in, check the coordinate systems, make sure they match. The other one is the image is in the right location, but it's hovering over the earth. Like this one here, if I was to turn this sideways, rotate the earth, you'd see that that's like 1,000 feet above the ground. Probably more like 100, but that is an elevation setting issue. So you just have to go into the settings, change the elevation label, snap it to the ground, and it'll plop it right on the ground for you. But those are some issues you'll see, and relatively easy to correct. Okay, saving and exporting layers. Once you've created a layer, as you can see, this is on Google Earth. You've got your layers, so you right click on the layer, and we'll go through this later on. I'll bring up Google Earth. You right click on it, and it'll bring up where you're going to save it to. But you give it a name, it'll say either KMZ or KML. And you select which one you want it to save it as. Now, KML is keyhole markup language. It's a file format for saving it. KMZ is just a zipped form of KML. So, and depending on what system you're importing it into, some of them like KMLs, some of them prefer KMZs. It's just a matter of figuring that out when you import them. So, but then you would make sure it's in the file format you want here, and then you'd save it to whichever location you want to save it to. And then when you import it into a GIS, you can either, some systems will let you click and drag, others you have to basically do a file drill down through the system to go get it. It'll have you search for it and pull it in that way. So saving layers. Questions to consider when you're saving it. Why are you saving it? For what purpose is it being saved? Because that may determine what format you save it in, where you save it to. Those things you'll need to consider when you're trying to save the layer. And obviously the systems you're saving the layer into or for use. So if you're producing something for somebody else and you can send it, you can just email them the KML or the KMZ, but are they going to be able to import that? Or are they going to have to change the format before they put it into the system, into their system? So you, depending on what your working relation is with them, you may want to change it to the format they need before you send it to them. Which leads us to system interoperability. So there are several systems out there. I've just got a couple of them up there. And in order to try and get them all to talk to each other, you have to understand what formats they need and use, because they all use different ones or prefer different ones. You'd think from ArcMap to ArcPro to ArcOnline, it'd be easy. It's all the right same system, right? Not so much. They have tools that you can save the formats to move it to the other ones, but yeah, you can't just save and instantly import it in. So here's some of the different requirements. Google Earth Pro works with KML and JPEG. You can pretty much just click and drag them in. ArcEarth imports KMLs easily. In fact, you can take your Google Earth KMLs and just directly click and drag them right into ArcEarth. ArcMap requires a tool conversion from a KML to a shapefile. And ArcPro requires a tool conversion from KML to shapefile. And ArcOnline, that would require the file format to be a shapefile, a CSV file, a GPX, or a GeoJSON. So that's what they need in order for you to bring them in. But fortunately, we won't be working with all those. So spatial relation, which is how does the subject relate to its environment? What is the impact of the subject on the environment? What is the impact of the environment on the subject? How do they influence each other, if at all? And what are the effects over time? Is it a one and done thing? Like it just has this initial impact and it's done, or is this an ongoing eternal thing? Is it going to keep having residuals forever and ever? Any questions? There being none, practical exercise time. Woohoo! So, using Google Earth Pro, create an imagery product utilizing point, polygon, and images and imagery layers. So, you've got those should all be in the download for understanding GIS. And your product is produce a product that defines the boundaries of North and South Dakota. I picked two easy states. And identifies their capitals and displays tribal boundaries as represented in the 1851 treaty map. So you're saying, holy cow. Let's bring this down and bring up Google Earth. Okay, so what I want to do is, and if you press the R button on your keyboard, it rectifies the world. So it turns it to north and you're all back there. So if you get all turned around, just remember, just hit R and it'll rectify it. So I want you to trace the boundaries. You can do that one of a couple of ways. And then identify the state capitals of the two. It's Bismarck and Pierre, in case you didn't know, I'm sure you knew. So, but before we get to that, I'm gonna try and bring up shape files here. Let's see. I'll show you a couple different things. Let's see this one. Okay, So there's a treaty map of the tribal boundaries and shows present day Wyoming. We'll probably use that one. So what we're gonna do on that, first we'll identify the capitals because that's easy. The metadata in a layer is usually contained in what is called an attribute table. And the attribute table in most things is a CSV, comma separated value Excel document. And that will give you the data you need to place the capital. And this is what it looks like. This is a basic model. So the attribute table. Let's go this out for you. You can do it one of a couple ways. So it pretty much always has an object ID, which is usually number 1, 2, 3, 4. Shape, this will be a point shape. Name, so Bismarck and Pierre. And then you have the latitudes and longitudes. This would be the X is the latitude and Y is the longitude. Z is for elevation. So if you had something you were bringing in that had a specific elevation, you could put the Z factor in there and it would add that to it. But this, by putting this information in, you could save your Excel document as, see which one this is. Okay, this is the Excel. You save your Excel as a CSV. So you just do a file, save as, and click on your drop down here and choose CSV. Oh, this one is a CSV. Okay. So that's what you do. You just go down and find CSV. It's here somewhere there. And click on that and save your Excel as a CSV. Then all you would need to do is you can click and drag that Excel into, or CSV into here, and it will populate. Let's see. Oh, it'll bring this up. And then you say, yeah, it's delimited, comma. Yep. So you're checking point, Bismarck, latitude, longitude. Or, yeah, latitude, longitude. Latitude field is X. If I got those mixed up and put them in the wrong order, what would happen? Anyone?
Looks like it's a whole different location.
They would throw me out into Eastern Uzbekistan or something. So yeah, you'd be not where you're supposed to be. Stream. Okay, that's right. So if it's a number, it's an integer. If it's a bunch of numbers or words, it's a string. I want to send a style somebody. Did it work? Yep. So your dot right there, and your dot right there. So put them on there. As you can see here, it stepped them down, but it didn't give them a name. So now you can go in and name those individually. Or you could put a column in your attribute table that would give it a name. So when you populated this, it would come up and it would say Bismarck and it'd say Pierre there. So we have those. That's how you make those dots on there. You can build an attribute table. Or you can put another one on there, like if you want to put Grand Forks on there, which is up here. Or there's a Rapid City, which is down over here. You could add those to them. Just find their latitude and longitude. Or the other thing you can do is you can do it instead of latitude, longitude, you can do it by address. So all you need to do is put the street address on there. And it'll do the same thing. It will put it in the proper place when you drag it in. So you can do it either way. So if you were like trying to map out where all your relatives live, you could just put their address. If you wanted to put their names, you could put their names, or you just put their street address or just their city or just their zip code. And it would put a pin on that map where you told it to put the point.